make use of rules. In the last session, we defined rules at the job level and saw how we can include or exclude jobs based on specific rules. And in this session, we're going to make use of rules at the workflow level and execute the pipeline based on multiple rules. So we'll be creating a new project in order to explore various other features of GitLab CI. So let me create a new project in the same demos group. So let me name this as generic project because I'll be using the same project for different, keywords and features of GitLab CI. I'll make this public. This will be in the demos group. I would like to have a README file and create. So here, let's configure CI/CD. Let us set up CI/CD. And let me quickly paste in a simple workflow. So I have a workflow name exploring GitLab CI concepts and a single job named deploy job. It has a script which is going to echo deploying application and another echo saying application successfully deployed to deploy variable environment. So I'm trying to use a variable here. And as seen earlier, you can define variables at the job level or at the global level, but we'll try to do something different. We'll try to, add variables based on the rules. So if you remember, if you go back to the rules keyword, you can also associate variables with the rules. If you go to rules and variables, so you can also add variables to the rules. And if that specific condition matches, it's going to make use of the variables which are defined for that specific rule, right? So today, I would like to add rules at the workflow level. So if I scroll up, and if you see here for the workflow, you can also define the rules, right? So this rules keyword is similar to the rules which we defined in the jobs, but this controls whether or not a whole pipeline is created or not. Okay, and again, you can use the variables even at this workflow level. So let's go ahead and add our first workflow rules. So let me add our first rule. So I would like to add a if condition, and I'm going to check if the commit branch is main or not. So I can use something called as CI commit underscore branch. And I'm just going to use the double equals operator and check if it is the main branch or not. So I'm only going to execute this pipeline if the commit branch is main. Okay. And for this branch, I'll also add a variable. So I can add a variable. So for the variable, I'm just going to use the deploy variable, which I just created. So I'm going to use a value, let's say, production. Okay, so I'm just going to use something different over here. So let me just define production value. Okay, I'm sorry. Okay, production. So you can also have multiple rules, but I'll add the other rules in the next exercise. So let me just deploy this, added workflow level rules, and commit it to the main branch. Okay, so I'm just committing it to the main branch quickly. So our new pipeline should be triggered. Let's go and check this out. So if you see, the pipeline is triggered because the condition is matching, right? So we have, committed to the main branch, and it should quickly run the job as well because we have a simple echo commands. So as soon as the runner is, up and running, it should quickly complete the job as well. So this is just for one rule. Okay, so I'm just waiting for the job to be completed, and the job is also completed. So if you see here, I use two echoes. So the first echo is deploying application, and the second echo is application successfully deployed to the production environment. So from where did it get this production value? So it's getting it from the deploy variable, which we have defined at the rules level. Okay, so similarly, I would like to add another rule. So rules can be an array. So I can add another rule. And for this rule, I only want to execute the pipeline if the source branch is feature. Okay, so let me go ahead and check if there is any CI merge request variable. So let me see. I think I have to go to the merge request, and here let me search if there is any variable. So I guess I will be using this variable CI merge request source branch name. So this is going to give me the source branch name of the merge request. So I would like to work with merge request. Okay, so let me just copy this CI merge request. Okay, I'm sorry. Let me copy this. Let me go back. Right, so I need to use a dollar in order to refer the value. And here I would like to use a regex. So earlier I used a equals to operator, but now I would like to use a regex. So how do I use a regex value? So again, you can go to the documentation. So if you want to do a regex pattern matching for a variable, you can either use the equal title or the exception operators. So I'm going to use the equal title operator over here. So I'm just going to copy this, and I would like to run this for a branch which is starting with the name as feature. So I'm going to use a regex pattern. So I'll just copy the pattern here, right? So I'm going to also run this workflow if the merge request source branch is feature. And you can also have multiple conditions. You can also use OR operators or the AND operator as well to check one or more conditions. So as for the second condition, I would like to also check if the pipeline source is a merge request event. So let me paste that, right? So this condition is going to check two conditions. So it's going to see if the merge request source branch is feature starting with the name feature, and the pipeline source is a merge request event. So if these are matching, it should execute the workflow. And you can also have additional conditions. So if it is matching the first two conditions, I'm also going to check that this gets only triggered if there is a change in any specific file or a directory. So I can use the changes keyword. So within the changes keyword, you can define the file which needs to be updated in order to, run this workflow. So in my case, I'm just going to use a README file because that's the only file which I have in this repository for the time being. But this could be any file like a Docker file or some changes in the test cases or some changes within the main script, right? So based on the requirement, you can add the changes. So this pipeline will trigger if there is a change in the README file, and if it is done on a feature branch which starts with the name feature, and if it is a merge request event. And if all the condition matches, it's going to trigger the workflow, and it will also use a variable. If you define a variable, deploy variable. So I'm just going to use testing for the time being over here. Okay, so I made these changes. So let me try to push this to a feature branch. So I'm just trying to push this to the feature branch, and I'll just name this as feature 2, or I'll just use feature branch, and I'll start a new merge request with these changes. Okay, so let's click on commit changes, right? So a new pipeline should not be triggered, ideally speaking. So let's go and see if there is any new pipeline triggered. Let me close this. So if you see, there is no new pipeline triggered because the conditions say that the pipeline should be only triggered if it is a merge request event. So we have not yet created the merge request. So once this request is created, it might trigger. Okay, so let me just go ahead and create the merge request. So the merge request is created. So let's see if any pipeline is triggered. Let me refresh. So the pipeline is not triggered. Why? So if you go back to the pipeline editor, so I need to go to the feature branch. So here, the first condition is matching. The second condition is also matching, but the changes is not matching. So we did not make any changes in the README file. As far as you remember, we just made a change in this gitlab4 YAML file and created that merge request in the feature branch, right? So if you go to the what we say in the merge request, you don't see any changes, right? So you should also have, I mean, you only see one change, and that is for the, GitLab file. It's not for the README file. So if you make changes to the README file in the feature branch, which gets added to this merge request, then the pipeline will be triggered. Okay. So let's go back. Let me go to code repositories. So in the feature branch, so I'll go to the feature branch. So I will edit the README file. So let me just edit the single file. So I'll remove everything. I'll just say, testing the rules, and let me quickly commit this, to the feature branch. Okay, so I have committed this to the feature branch. I just, made a change to the README file. So let me go back to the pipeline. So in the pipeline, if you see, as soon as I made a change to the README file and committed it, a new pipeline got triggered. Okay, so now this is for the merge request. You can also see the merge request icon. So let me go back if you missed it. So if you see for this pipeline, so this is getting triggered for the merge request. Okay, so let me go here. Let me open the job. And the job is also successfully completed. And if you see, it is making use of the testing variable which we have defined at the rules level. So if I go back and refresh the merge request, so there are two changes. So now we also made a change to the README file. Since the change was there in the README file, it triggered the workflow, right? So if I go back to the pipeline editor for the feature branch, so all these three conditions got matched, and hence it was, triggering the workflow and using this variable for the deploy job. So that is how you can make use of the rules keyword, have various conditions with regex patterns and operators, depends on the changes in the file. And you also have few more settings which you can, explore within the documentation and make use of them in your real-time projects. So that's all for now. Thank you. Let's talk about pipeline schedules. So far, we have triggered the pipeline by committing, messages, or by committing changes to a main branch, or when we created a merge request. But now let's explore the pipeline schedules, right? So it's under the build option. So let's go to pipeline schedules. So this is nothing but it's going to schedule a pipeline start automatically at regular intervals like daily, weekly, monthly, or based on a cron job. So the pipeline is going to run for a specific branch or tag, and it can also have some custom CI/CD variables as well. So let's go ahead and create one. So let me just provide a small description about this pipeline. So this is going to be a manual pipeline trigger. So we are going to manually trigger this, and you can also give the interval pattern. It could be every day around 9:27 p.m. It could be weekly or monthly. And if you see, whenever I'm selecting these patterns, it's also using a cron expression or a cron syntax. Or you can also give your own cron syntax as well. So if you're familiar with cron, you can give your own values over here. So let me just provide my value over here. So I'm just going to execute or schedule this pipeline to run once every year at midnight of 1st January. Okay, so if you're not familiar with how the syntaxes work, you can just go ahead and check out what is cron syntax and how to schedule it. You can also select a time zone. So I really don't care about the time zone for the time being, because I'm just doing this for a small demo part. So I'll just select, let's say, Mumbai. Okay, and you can select for which branch you would like to run this for. And if you remember, this project has two branches, the main branch and the default branch. So I'll just select the main branch, and you can also give variables or files which can be accessible by the pipeline. So I would like to hard code deploy variable. So if you remember, our pipeline uses a deploy variable. So I'll just give this a manual value. So I'll just say manual. It's deployment, not development. So I'll just say manual deployment. That's it. So I'll also say that it's activated so that it runs once, every midnight on the 1st of January. And let me just, create the pipeline schedule. So once it is created, so you can have multiple pipeline schedules and it's going to, run based on the cron syntax which you have provided. And as you can see here, it does not run any pipeline so far. And the next run is around 11 months because, today it's January, right? So that's how it's going to run. But I don't want to wait for 11 more months, so I can manually, run the pipeline. So let's trigger this manually. So a new pipeline has been successfully scheduled to run. I can go to pipeline stages page. And here, if you see, a new pipeline is running. And before going to the job, I also want to show you the tag. So if you see here, it's going to show a scheduled tag. It's saying that this pipeline was created by a scheduled. So if it is executed or started using a merge request, you see the merge request tag, right? So these tags are also useful to understand how the pipeline was created, or which triggered the pipeline. Okay, so let's go and check out the job. So we only have one job which successfully passed. So let's go and see the variable. So if you see here, the variable is manual deployment. So this is the variable which we have, declared, within the pipeline scheduled option. So it's going to make use of the variables which you add in the schedule, during the runtime of the job. So that's how you can schedule pipelines, run them manually, and also edit them if required. That's all for now. Thank you. Let's have a look at resource groups. In GitLab CI, multiple pipelines run concurrently, but in some cases, such as the deployment cases, you don't want to run the jobs concurrently and you want to run them one by one. So this is the place where resource groups comes into the picture. So if you want to know more about resource groups, you can go to the CI/CD YAML syntax reference and search for resource groups. So you can use a resource group to create a group that ensures that a job is mutually exclusive across different pipelines for the same project. For example, if multiple jobs that belong to the same resource group are queued simultaneously, only one of the job starts. The other job waits until the resource group is free. And again, you have various process modes which can be used to strategically control the job concurrency. And the default one is unordered. Okay, so let's check out what are the different modes available, and then we'll check out a demo as well. So let's check out the different process modes. So we have three types of process modes: unordered, oldest first, and newest first. And the default process is unordered, where the execution order of the jobs is unordered, which means that any job can start first and the others will be queued. So let's take an example and try to understand these three process modes. So if you come down, there is an example where you have two jobs, the build and the deploy job. And let's assume you have done 3 commits to the same pipeline. So what happens here is, in the first pipeline, it's going to run both the build and the deploy job. So let's call this as deploy 1. Similarly, the second and the third pipelines are called as deploy 2 and deploy 3. So we have 3 deployments. Okay. So depending on the process mode, so this is how it works. So within the unordered process mode, since we have this 3 deploys, they do not run concurrently. So, and there is no guarantee on the job execution order. So for example, job deploy 1 could run before or after the deploy 3 or the deploy 2. That's the unordered mode. And whereas coming to the oldest first mode, So if you have deploy 1, deploy 2, deploy 3, so deploy 1 is going to run first, then deploy 2, followed by deploy 3. So that is how the oldest first works. And the opposite of this is the newest first. So in the newest first, it's first going to run the deploy 3, then the deploy 2, followed by the deploy 1. So these are the three modes available, and the default mode is the unordered. If you want to change the mode, you need to make use of the GitLab CI REST API to change the mode. Okay, so now let's try to use the resource groups in the unordered fashion. So in order to use a resource group, so this is what you need to mention in your job. So let me just copy this, go to my pipeline, and I would like to just mention the resource group for my deploy job. And the value could be anything. I'm just using production as an example, but it could be any value. Okay, so let's quickly commit this to the main branch. And I also want to add a sleep command as well, just to show you how this works. And I'm just going to add a sleep of 300 seconds. Okay, it's around 5 minutes. So let me just commit this to the main branch. So if I go to the pipelines, a new pipeline should be triggered. So if you see a new pipeline is triggered and it is running. At the same time, if I schedule a pipeline manually, so let's go to pipeline schedules and let me, run the pipeline manually. Okay. So again, this is going to run for the same main branch, right? So if I go to the pipelines and if you see, there are two pipelines running, whereas the second pipeline is waiting. The reason it is waiting is the deploy job is already running in the first pipeline, which I triggered when I committed it to the main branch. So if you see, the deploy job is running. Since the deploy job is already running, which has a resource group keyword available, so any other job which is trying to run the deploy job or any other pipeline which is trying to run the deploy job will be in the waiting stage. So if I go back to my pipelines, since the scheduled job is also trying to execute the same deploy job, it will be in the waiting state. If you see, it is in waiting state. So if I open this, it's going to give you additional information saying that, this job is waiting for resource protection. So any jobs which is using the resource protection should complete or should be cancelled in order to start this waiting job. So let's do one thing. So let's go to our pipeline and cancel the first pipeline. Okay. So how do you cancel the pipeline? So if you want to cancel the pipeline, you can simply click on cancel the running pipeline. Or if you want to just cancel a specific job within the pipeline, you can also cancel the job as well. So you can do either of them in this scenario because we only have one job running, right? So as soon as I cancel this pipeline, this job should automatically trigger. Okay. So let me cancel the first pipeline. So this is canceled. And if you see here, automatically this job gets triggered because the other job was canceled and the resource group production can accept another deployment, right? So that is how you can make use of the resource groups so that you can control the concurrency of the job trigger points. So if I go back to the pipelines, so you should see that the pipeline which is cancelled has an icon cancelled, and the pipeline, the scheduled pipeline is in running state now. Okay, so that's about the resource groups. And in the next session, we'll talk about how you can make use of job timeouts as well. That's all for now. Thank you. Let's talk about job timeout. While working with jobs, script errors or dependency issues can sometimes indefinitely run job executions, causing pipelines to stall and consume resources. In such cases, implementing timeouts automatically terminates the jobs, optimizing resource utilization and pipeline execution speeds. So how do you configure timeout for a specific job? So you can go back to the CI/CD YAML syntax reference and search for timeout. So you can configure a timeout for a specific job, and it's going to, fail the job if the job runs longer than the timeout. And you can, define the timeout using natural language like 3600 seconds, 1 hour. It could be also like 3H30M, which translates to 3 hours and 30 minutes. So all you need to do is use the timeout keyword along, with the time unit which you want to use. So let's go back. And this job generally takes more than 5 minutes to complete because we are using a sleep command. So what I can do this, so I can use a timeout keyword, and I just want this job to complete within 10 seconds. If the job doesn't complete within 10 seconds, I want to terminate the job. So that's what the timeout keyword is going to do. So let's go ahead and commit the changes. So let's go and check out the pipeline. So I can click on the view pipeline here, right? A new job has kicked in. And this job will only wait for 10 seconds. If it takes more than 10 seconds, it's going to, simply fail the job. And as you can see here, this job failed right in pulling the Docker image for Ruby 3.1. Okay. It's saying that, context deadline exceeded, because we just gave it 10 seconds, right? So as you can see the time over here, so it worked for 10 seconds, and on the 11th second, it just terminated the job because of the timeout keyword which I have used. So it's going to just fail the job, and it's going to say that there has been a runner system failure. Please try again, right? So this is how you can use a timeout function. I just used 10 seconds as an example to show how quickly I can, fail the build. But this value should be a meaningful value as per your job and, how much time is required for it, right? So that's how the timeout works. Thank you. Let's go ahead and understand how you can run the jobs within a specific Docker image. So if I go back to my workflow, so I would like to make some changes. So let's assume I would like to deploy a Node.js based application. But before deploying the Node.js application, I just want to check out what is the Node version I have. So I can use Node-v. And at the same time, Node.js also uses a package manager for installing the dependencies, and it is called as npm, Node Package Manager. So I would like to check out the versions of both this before I deploy the Node.js application. And I just want to remove or comment out the timeout thing. Okay, so let's try to get the versions of this two commands using the default image. Okay, so let me quickly commit this. I can go to the pipeline. So a job will be triggered, and I'll just pause the video till the job gets completed. Okay, so now the job is completed, but you can see the job failed. So let's understand why the job failed. So let me just minimize all the steps. So if you go with the default job image, if you remember, it uses Ruby as the default Docker image. So all your job script commands will be running within this Ruby container. And hence this is the Ruby container. It does not have any Node.js program installed on it. So it cannot, give you the version of Node, or it cannot access the, Node or npm CLI commands. And hence it's going to say command not found. So what do we do in such cases? So one option is to manually install Node.js on the Ruby container. So what you can do is, you can create a before script, right? And, you can just have all the commands to install the Node.js. So what you can do here is you can go to the Node source website, or you can use any other website where it gives you the steps for installing Node.js of the version 20.x. So here it's going to use sudo apt-get update. It's going to install some certificates, download the Node.js software, and it's going to finally install Node.js, right? So let's copy these commands and let's try to install it and see how it works. So if I come here, I can just paste this, but again this is going to give you an error because this is like multi-line commands. So for each line you have to properly use YAML syntaxes and do the proper formatting. So instead of formatting each line individually, so what we can do is you can use a long command. So there is a YAML syntax which can be used for running multi-line commands. So if you go to the GitHub or GitLab documentation, so it also has a section where it explains how you can split long commands, right? So it makes use of the YAML multi-line block scalar indicator. You can use a literal in order to define multi-line command. So you simply have to use a literal over here. Okay, so let us use this here, literal, and yeah, I guess you just have to format this. That's it, right? So if you see there are no more errors, so each line will be treated as a command and executed separately. Okay, so let's quickly commit the changes and see how this works. So a new pipeline will be triggered. So let's go back to the pipelines. So a new job is running. So I will be pausing the video till the job completes. Okay, the job failed again, but with a different error. So I think it's saying that it cannot find the sudo command. So I guess I have to get rid of all the sudos within the before script, which I just copy pasted. So I think I have around 6 sudo commands or 6 sudo words. So let me quickly remove all of them. Okay. Okay, so I guess I got rid of all the sudo commands. Let me quickly commit this again. So a new pipeline is again triggered. Let's go to that pipeline. I'll be again pausing the video till the job gets completed. Okay, so now if you see the job is successfully completed, so let me just minimize the steps and go through them. So it is still making use of the Ruby Docker container image. It's running the container. It's executing the before script where it is downloading all the certificates, downloading Node.js and installing it. And once Node.js is installed, if you see, it was able to execute the node and the npm commands, and it was able to give out the versions. But this is a bit hacky, right? So because we are trying to install and run Node.js within the Ruby container, right? And it took almost around 30 seconds to do this stuff because you're manually installing stuff and using it. And this might be a very simple installation which took just 30 seconds, but in some other scenarios, if you want to manually install software and then use it, it might take a lot of time, right? So how do we avoid this, right? So one way is, instead of using a Ruby image which comes by default, can we use any other image which will help us to improve the performance and also decrease the duration? Since we are making use of a Node.js program or a Node.js based application, it would be better to run the jobs using Node.js image instead of Ruby. So how do we do that? So within the jobs, you can make use of the images keyword. Again, you can find the documentation within the YAML syntax reference. So you can use the image keyword to specify a Docker image that runs the job, right? So again, this can be given at the job level, or it can be also given in the default section. If you give it in the default section, all the jobs use the same image for running the scripts. And if you mention it only at a specific job, only that job makes use of it. And of course, you have various options. So you can give the Docker image name. In some cases, you can give the entry point of the image or the container. You can mention the pull policy, right? So you have different options available. So which image do I want to use? So I want to use a Node.js based image, which is available in Docker Hub. So if I come to Docker Hub and if I search for Node, it has a lot of image tags. So I would like to make use of, this 20 Alpine 3.18 tag. So what and how can I use this tag? So all I need to do is I need to go back to my pipeline, remove the before script because I don't need the script because now I will be using a Node.js based image. So you can just use the image tag and provide the Docker image name. So let me just give node colon 20 hyphen alpha or alpine 3.18, right? So that's the only change which I have to do. Let me commit the changes. Let's go to the pipeline. Okay, this is still in pending. So I guess the previous job is not yet completed because if you remember, I'm still using, I'm not sure why it's pending. Okay, let me just check it out. Okay, it's still pending and it's waiting for a runner to be picked it up. So let's wait for a minute because we are using the GitLab shared runner. So it might take some time, in order to select a runner if all the runners are busy. But now if you see after a few seconds, the job was picked up by a runner and it also got executed successfully. So this time it just took 13 seconds because we are not installing anything. We are directly using an image, right? So let's minimize the steps and see what happened differently this time. So let's start with the first one, preparing the Docker machine executor. And here you see that it is making use of the node image, which I mentioned within the job specification. So this image is going to be used to create a container and the job will be running within this container. So since we have a node container, you don't need to separately install Node.js and these commands will be directly available, within this container. And that is how you can use images so that you can run your jobs within that specific container. That's all for now. Thank you. In this session, let's go ahead and understand the GitLab CI's parallel keyword. So let's take an example. So let's assume you have an extensive test suite of more than 100 test cases which has to be executed. And if you have a single test job which is running all these 100 test cases, it may take a lot of time to complete the unit testing or any other testing. So let's assume it's taking you around 20 minutes to run all those 100 test cases. So this is the place where the parallelization comes into picture. So using the GitLab CI's parallel keyword, you can significantly reduce the pipeline's duration. So if you go to the CI/CD YAML syntax reference, so there is a parallel keyword. So this keyword or this can be used to run a job multiple times in parallel in a single pipeline. So GitLab allows you to, split your work into multiple jobs and then run concurrently, improving the overall pipeline speed. So let's assume if you have 100 test cases, so you can use a parallel job of 10 jobs and you can split those 100 test cases across this 10 jobs. So each job is going to, run 10 test cases. So overall, at the end of the day, it would, highly reduce your pipeline duration from 20 minutes to, let's say, 10 minutes or 15 minutes, right? So that's how the parallelization works in GitLab CI. Apart from the parallel keyword, we also have something called as the parallel matrix. So using this matrix, so you can also run jobs multiple times in parallel within the single pipeline, but using different variable values. So let's try to understand this with an example. So if I go back to my pipeline editor, so here I'm trying to, run this deploy job or basically to get the versions of Node.js and NPM, by running this on a specific node image. What if I want to deploy or test the same thing on multiple node images or on multiple versions and also on, multiple different runner machines? One way is to, simply copy pasting the same thing and changing the versions. So again, this would create two jobs and it would run on two different Docker images. But this is not efficient if you have a larger set of things to test. So this is a place where you can make use of the parallel matrix. So how can you use that? So you can use the parallel keyword, and you can also use a matrix. So you have to define a set of variables here. So first let me define the runner machine. So I would like to run this job on a couple of different machines. So let me just copy runner machines, and let me just run this on, let's say, the SAS small Linux machine and the SAS medium machine. So let me just paste the values, right? So I would like to run this job on these two machines. And if you want, you can also use Windows and Mac OS as well. So you have to give the right tags. So once you define this matrix, so if you want to make use of this variables, of course, you need to make use of tags in order to, associate this job with a specific runner machine. So here, earlier, we were hard coding the value, but now you should not be hard coding. So you should be getting the values, from the runner machine parallel matrix variable. So how do I get that? So I can make use of dollar, and I need to use the run machine. So as soon as I do this, so now this job is going to run 4 times on this 4 different runner machines. So let me see if I can also see this in visualize. Okay, it's not showing me over here. Let's see if I can see this in validate. So let's validate the pipeline. And as you can see here, it is showing me 4 separate jobs. So each job is going to run on a different runner machine. But ideally speaking, in the actual editor, we only have a single job, but using the parallel matrix, it's going to run the job on 4 different runner machines. So let me see if this can also be visualized in full config. No, it won't visualize here, but yes, in validate, you can see that it's showing you 4 different jobs. Okay, so this is like a single level of matrix, but I only want to run this on the 2 machines, like the Linux machine. So I'll just remove the Windows and the Mac OS. So apart from this, let's say I also want to run this job for different Node.js versions to test it or to deploy it on different Node.js versions. So how do I do that? So within the same matrix, I can define another variable. I can give this any name. I'm just using node version as the name, or node versions. And here again, I can give, a array of versions. So I would just like to give 3 versions over here. So let me quickly copy the versions. Right. So I would like to run this on the version 18, 20, and 21. So again, I need to copy this and use a dollar value to refer the node versions, right? So now this single job will be run 6 times in parallel because we have 2 runner machines and 3 node versions. So each version will be running on both the machines. So since we have 3 versions and 2 machines, 3 multiplied by 2 is 6. So total 6 jobs will be running in parallel using this single configuration. I think we can also see this within the validate. If I validate the pipeline, I should be seeing 6 jobs, right? So each job is using small. So let me just do small. For the small machine, it's going to run all the 3 versions 20, 18, 21. And for the medium machines, again, it's going to, use the same node versions. Okay. So I think I made one more small mistake over here. So I need to use node colon the version, because I'm only dynamically changing the version. I'm not changing the image name. I'm only changing the tag. So I can say tag instead of version. I can say tags. So let's try to commit this. Let's go to pipeline. a new pipeline got started. And here we have a single job, but if you see there is a number 6. So if you try to hover your mouse on top of it, it's going to show you that there are 6 jobs which are triggered in parallel, and all the jobs will be running in parallel. If you click on jobs, you can see the same thing. But the thing is, some of the jobs are in waiting state because the runners might not be available at the time. So as soon as the runners are available, it's going to execute the remaining jobs as well. Currently, let's go to this job which has passed. So this job is running on the Linux small runner machine, and it's making use of the node tag 20, version 20. So if you go down, you should be seeing that the node version is 20. And let me see if anything else has completed. So this is for the job which is using the small Linux machine, but version is 18. So the node version in the logs should also be 18, right? So similarly, all other jobs will be running based on, the different machines and the version. So let me just go to one other job. So this is using the Linux medium machine, and the node version is 21. So if I scroll down, it should show you the node version as 21. Okay. So that's how you can parallelize your jobs. So I just used the parallel matrix job to show you how to use multiple variables and run multiple jobs in parallel. If you don't want to use variables, you can simply use the parallel keyword and run your jobs parallelly in multiple different jobs, so that you can quickly run the test cases by splitting them across multiple jobs. So that's all for now. Thank you. So let's understand why we need to skip a pipeline and how to skip it if required. So let's say in some scenarios, you might not make any changes to the workflow editor or the pipeline, or you might not make any changes to the code within your repository, but you're making some small changes in the README file, or you're making some changes in the .gitignore file. So in those cases, you don't want to execute or trigger a pipeline because that is irrelevant to your pipeline code. So how do you skip pipeline triggers in those scenarios? So this is where you can skip a pipeline. So whenever you're pushing a commit, and if you don't want to trigger a pipeline, you can add skip CI or CI skip within the commit message, and it won't trigger a pipeline. So let's try to quickly check this out. So let me go to README file. Let me edit this file. So let's say testing skip pipeline. And in the commit message, if I commit this is going to trigger the pipeline. But ideally speaking, I did not make any change in the code or any pipeline changes. So triggering a pipeline for this scenario is illogical. So you can simply skip the pipeline trigger using the skip CI. You can just mention this in the commit message and commit it. And this won't trigger any pipeline. So if you see here in this icon, it simply says that the pipeline is skipped. So if you go to the pipelines tab, build pipelines tab, it's going to show you the status. It's saying that, for this specific commit, the pipeline was skipped. Okay. You won't see, any jobs. It's simply saying that the pipeline is skipped over here, right? So this is how you can skip pipelines when you don't want it to be triggered for specific commits within your repository. Thank you.